Hello everyone, my name is Franco Pucci. I'm the technical consultant for the STS Association. Welcome to Training Video Series 2, where we will explore the companion specifications. I hope you find these videos helpful. In this video, we will look at the S201-1 companion specification. Please refer to the relevant document for detailed descriptions. And it's the STS201-1 meter function object register table for payment meters. We will discuss a few of the defined registers. For the rest, please refer to the document. So if we look at a reference model for prepayment, you have a meter function object with a function object identification number of 15-1.2, and it's defined as an in or out function object. Associated with that is a register table with table ID of the foin above. That looks at a register array, and that array can contain between 1 and 65535 registers. So the function object identification number, or foin, is allocated by the STS Association. Only one foin has been allocated so far. The register table contains one register and up to 65535 table entries. In these table entries, there's a register name, a register identification number, a format, a read or write flag, confidentiality attribute, and authentication attribute. So let's look at a typical register table. We have the name, and it's the attribute name is table and the table ID. The range is a register table and the foin is 15-1-2. The context is a registered name of the function object in the companion specification. And the foin is the function object identification number as registered in the companion specification. The data elements is a register array, and it's an array of simple or complex registers between 0 and 65535. The context, external data interface to the function object from the token carrier perspective. The methods, no methods. Operation, no operation. It's got no operational functionality. And the association, the associations are defined per register instance. The register table does not make use of any other specified services for its functioning, in other words. Okay, so if we have a look at a subset of this now, under register ID, it goes from 0 to 1 FFF. 2000 is a protocol version. 2001 is a table ID. 2002 is a service status, and you get a software version binary token entry. In other words, register number 2004 is where you can put a binary token entry into the meter. If you look at the column read-write, it shows you whether it's a read-only. For the first 4, read-only. The binary token entry obviously is a write register. Token lockout time remaining is 2005, and that's a read. And 2006 contains the decoder reference number for 11 digits. There's a separate one for 13 digits, so that's a read. And then you get reserved registers from 202C up to 8FFF. And then 9000 to FFFD are proprietary reserved registers. In this case, authentication is required. All the others are not required. And then you have FFFE, which is the token status. That's a read register, and that'll give you the status of the last token entered. And then you can read whether it was authentic or not, etc. And then FFFF, which is the numeric token entry. So if instead of the binary token entry for a token you want to put in the numeric token itself, then you can enter it at register ID FFFF. That is also a write register. It's not a confidential register, and there's no authentication required for it. Let's look at an example, and the example I've chosen here is a decoder reference number for a 2-digit manufacturer code. The register name is decoder reference number. The register ID is 2006 hex. The format is 11 decimal digits. It's a read-only register. There's no confidentiality and no authentication. In other words, under confidentiality, the contents are not confidential and the client authentication is not required. Data elements, as defined in 62055-41 in 6.1.2.3. It's an 11-digit decoder reference number. Method would be a read command with the register ID, and DL is in fact ignored by the server. It returns the value of the decoder reference number read from that register. So the data may be retrieved from the register by sending a read command message to the server with this register ID in the RID field. The DL field is ignored. Operation, it's a virtual record in the meter, and the meter keeps a virtual record of the value of the decoder reference number. Remember that this object merely defines a virtual register. That register would then point to the place in the meter's memory where the decoder reference number is actually kept. Okay. Another example would be supply group code. For example, that's register 201-6. It's 6 decimal digits. It's a read or write. And the reason for that is that you want to read what the current SGC is. You may do a key change and may want to write the new supply group code in to that register if it's not a 3 key change or 4 key change token set. Obviously, with the 3 or 4 key change token sets, the value of the new supply group code is written into the meter automatically, but with the 2 digits it's not. So you may want to access this register to put the new value in. The supply group code attribute then is a 6-digit SGC as defined in 6.1.6 of 62055-41. And for a read command, you send the register ID. DL is ignored. And for a write command, if you want to set it, then you send it again to the register ID. And in this case, D is a 6-digit supply group code. So the data may be received by doing a read command, or it may be written by doing a write command. Okay. Some notes on the SGC register. A client may set this register to any desired value at any time, but whenever the decoder key in the payment meter is changed, then the payment meter shall set this value of this register to 0. Okay, and you can find reference to this in 62055-41. If the payment meter supports only 2 key change tokens in a key change token set. So, just to summarize, if it's only 2 key change tokens going in, the meter must set this register to 0 after having done the key change. If the payment meter, on the other hand, supports 3 or 4 key change tokens in a key change token set, then it shall set this value to the value of the SGC transmitted with the key change tokens. The value is right justified and left padded with 0 to make the full 6-digit code. Placing of a value into this register by a client is an uncontrolled event and does not necessarily reflect the actual value used in the point of sale database to generate the decoder key for a particular payment meter. Okay, so if the supply group code is not contained in the key change token set, then the value in that register could be in fact written incorrectly by using this register to write it in. So please bear that in mind. It's an uncontrolled method. If we look at the numeric token entry register, for example, the name is numeric token entry. It's registered the ID FFFF. In fact, it's the very last register. The format is 20 decimal digits, 0 to 9. It's a write-only register. There is no confidentiality or authentication required. So it's 20 decimal digits going in as defined in 5.3 of IEC 62055-41. The method is write command with the register ID and D, where D is the 20-digit decimal number. The data may be loaded into the payment meter via the register interface by sending a write command with the register ID value in the RID field you see on the left, and the data set in the D field. Okay, so that's the context. And this provides a virtual point of entry for a token to a prepayment meter as another token carrier interface. So in other words, you could use this register to send a token remotely via some other means, some other connectivity, using a port type A or B that was discussed in a previous video, and send that to the meter. That is a possibility. Some notes on the supply group code register. For all other register definitions, please refer to the STS201-1 meter function object, register tables for payment meters document. That will contain a full list of all the other register definitions. Thank you. This brings us to the end of this part of the video series. I hope you found this video helpful, and I hope to see you for the rest of the video series. Goodbye and see you again soon.